This is SpaceTime Series 24, Episode 142, for broadcast on the 24th of December 2021. Coming up on SpaceTime, a new study shows that most of the Milky Way satellite galaxies are new to the neighbourhood, discovery of the largest comet ever observed, and New Zealand launches its 6th Electron mission this year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that most of the 50 satellite galaxies surrounding the Milky Way are new to the neighbourhood and are only on their first pass of our galaxy. The findings by the European Space Agency's Gaia spacecraft are rewriting the history of our galactic neighbourhood. A dwarf galaxy is a collection of between thousands and several billion stars. For decades, it's been widely believed that the dwarf galaxies surrounding the Milky Way are satellites caught in orbit around our galaxy, and have been doing so for billions of years. But now the motions of these galaxies have been computed with unprecedented precision thanks to data from Gaia's early third data release, and the results are surprising. The Gaia data suggests that the three-dimensional velocities of 40 of these galaxies indicates they're moving much faster than the giant globular clusters known to be orbiting in the halo of the Milky Way. This means that they couldn't be in orbit around the Milky Way, at least not yet. That's because interactions with our galaxy and its mass would have sapped their orbital energy and angular momentum, slowing them down. Over its 11 to 12 billion years of existence, the Milky Way has cannibalized a number of dwarf galaxies. For example, between 8 and 10 billion years ago, a dwarf galaxy called the Gaia Enceladus was absorbed by the Milky Way. And even today, astronomers can still identify the stars in our galaxy which were once part of Gaia Enceladus. That's because their orbits and speeds are slightly different to the stars which were actually born within the Milky Way itself. More recently, between 4 and 5 billion years ago, the Sagittarius dwarf galaxy was also captured by the Milky Way and is currently in the process of being pulled to pieces and assimilated. The energy of the stars in Sagittarius dwarf are higher than those of Gaia Enceladus, indicating the shorter time that they've been subjected to the Milky Way's influence. In the case of the dwarf galaxies in the new study, which represents the majority of dwarf galaxies around the Milky Way, their energies are much higher, and this strongly suggests that they've only arrived in the Milky Way's vicinity in the last few billion years. The discovery mirrors one made about the Large Magellanic Cloud, a larger dwarf galaxy so close to the Milky Way that it's clearly visible to the unaided eye as a smudge of light in the night sky in the southern hemisphere. Until very recently, the Large Magellanic Cloud was also thought to be a satellite galaxy of the Milky Way. But when astronomers measured its velocity, they found it still travelling too fast to be gravitationally bound. Instead of being a satellite, it seems the Large Magellanic Cloud is visiting our neighbourhood for the first time. And we now know that the same must be true for most of the Milky Way's other dwarf galaxies as well. The discovery of the dwarf galaxy's energies is significant because it forces scientists to re-evaluate the nature of the dwarf galaxies themselves. As the dwarf galaxy orbits, the Milky Way's gravitational pull tries to wrench it apart. In physics, this is known as a tidal force. And the Milky Way is a big galaxy, so its tidal force is simply gigantic, and so it's very easy to destroy a dwarf galaxy after maybe 1 or 2 passages. The only thing that could resist our galaxy's gravitational grip is if the dwarf galaxy itself contained a significant quantity of dark matter. Dark matter is a mysterious invisible substance which makes up over 75% of all the matter in the universe. Although astronomers can't see it, they know it exists because they can see its gravitational force on other galaxies, holding them together as they rotate. And so, in the traditional view that the Milky Way's dwarfs are satellite galaxies that have been in orbit for many billions of years, it was assumed that they must be dominated by dark matter in order to balance the Milky Way's tidal forces and keep them intact. But the fact that Gaia has revealed that most of these dwarf galaxies are circling the Milky Way for the first time means they don't necessarily need to include any dark matter at all. And that means scientists will need to reassess whether these systems are in balance, or rather in the process of destruction. This is SpaceTime. Still to come, the largest comet ever detected, and New Zealand launches its 6th Electron mission this year. All that and more still to come on SpaceTime. A new study shows that the comet Bernardinelli-Bernstein, the largest comet ever discovered, became active far earlier than previously thought. The findings, reported in the Planetary Science Journal, means the ices within the massive comet began sublimating and vaporizing, forming an envelope of dust and gas known as a coma around the comet, far further out from the Sun. The findings will help astronomers determine what this 100-kilometre wide comet is made of, and provide new insights into the sort of conditions that existed during the formation of our solar system. Only one other active comet has been observed further out from the Sun, and it was much smaller. The study's lead author, Tony Farnham from the University of Maryland, says the new observations are pushing the distances for active comets dramatically further than previously known. You see, knowing when a comet becomes active is key to understanding what it's made of. Often known as dirty snowballs or icy dirt balls, comets are conglomerations of ice and dust left over from the formation of the solar system. As an orbiting comet gets closer to the Sun, it warms and ices begin to vaporize. How warm it needs to be to start vaporizing depends on the kind of ices it contains. Water, carbon dioxide, carbon monoxide, ammonia and other frozen compounds all have different vaporization temperatures. Scientists first discovered comet Bernardinelli-Bernstein back in June, using data from the Dark Energy Survey, a collaborative international effort to survey the skies of the Southern Hemisphere. The survey captured the bright nucleus of the comet, but didn't have enough resolution to reveal the envelope of dust and vapor that forms when the comet becomes active. At 100 kilometres across, comet Bernardinelli-Bernstein is the largest comet ever discovered by far, and it's still further out from the Sun than the orbit of the planet Uranus. Most comets are just a couple of kilometres across, and they usually become active once they're inside the orbit of Jupiter. So Bernardinelli-Bernstein is very different. Farnham and colleagues found additional images of the comet in data captured by NASA's Transient Exoplanet Survey satellite TESS, which observes one area of the sky for 28 days at a time, and so provides longer exposure times, which would provide more detail. The authors were able to combine thousands of TESS images of the comet taken between 2018 and 2020, stacking the images together electronically to increase contrast and get a clearer view. The size of comet Bernardinelli-Bernstein and its distance from the Sun suggest that the vaporizing ice forming the coma at the moment is dominated by carbon monoxide. Since carbon monoxide can begin to vaporize when it's up to 5 times further away from the Sun than where comet Bernardinelli-Bernstein was when it was discovered, it's highly likely that Bernardinelli-Bernstein was active well before it was observed. This is SpaceTime. Still to come, New Zealand launches its 6th Electron mission this year. And later in the science report, good news if you're a coffee drinker, scientists have found a link between coffee consumption and a lower risk of getting Alzheimer's. All that and more still to come on SpaceTime. Rocket Lab has successfully deployed another 2 BlackSky satellites into orbit. The A Data with Destiny mission, the 6th and last for the year, was launched aboard an Electron rocket from the company's Mahia Peninsula launch complex on New Zealand's North Island east coast.
Vehicle is on internal power.
LOX load is complete. System is in recirculation.
Tanks are pressed for flight.
High flow engine purge enabled. Deluge activated.
10, 9, 8, 7, 6, 5, 4, 3, 2.
Voltage pressure discharge nominal.
And away we go. Our 23rd Electron launch vehicle is off the pad and on the way to space for this mission and progressing well on its journey to low Earth orbit.
Cleared max Q.
There's the call out from Mission Control. Electron has successfully passed through Max Q and is continuing eastward off the coast of New Zealand. The first stage's Rutherford engines are firing red hot and nominal as we come up to a vital sequence of events in the vehicle's launch procedure. Electron will slow down just a touch before shutting off its main engines, what's called main engine cutoff, or MECO. This allows for the clean separation of the first stage from the second stage before the second stage's engine lights up and propels the vehicle's satellites onto orbit.
Stage 1 propulsion is holding nominal. Standby for MECO. MECO confirmed.
Stage separation successful.
Stage 2 ignition.
And there we go. That's confirmation of successful MECO, stage separation, and second stage engine start. Now, since we've cleared the lower atmosphere, we no longer need the rocket's fairing to protect the satellites, and we need the fairing out of the way to be able to safely deploy the satellites. So soon that fairing will fall away as we get rid of the dead weight. Electron's fairing halves have been deployed. We've got a short time gap now between this event and the next one coming up for Electron's second stage, which involves swapping out the batteries that power the second stage Rutherford engine. The mission is continuing nominally, though, as we approach that next milestone, with the second stage travelling at a speed of nearly 10,000 kilometres an hour at an altitude of over 130 kilometres. Electron's second stage, with the BlackSky satellites on board, is headed to a circular low Earth orbit 430 kilometres above Earth, where they'll join the rest of BlackSky's constellation of Earth-observing smallsats, 2 of which we deployed on our last mission just 21 days ago.
Throttling down.
Stage 2 propulsion holding nominal.
We're coming up to a milestone unique to Electron soon, the swap out of the batteries that our Rutherford engines draw their energy from to continue, as our engineers say, chooching. The vehicle has run through the set of batteries we started with at liftoff, and so now the second stage of the vehicle needs to swap over to a fresh one to keep things going. We call this move the battery hot swap. You should hear that call come from Mission Control shortly.
Hot swap successful.
And so there they go, and that was the call for a successful battery hot swap. Coming up in the next couple of minutes will be the second engine cutoff on the second stage, or SECO. This manoeuvre follows pretty much the same procedure as main engine cutoff, where the Rutherford engine on the second stage will shut off ahead of final separation of the vehicle between the second stage and our kick stage. There will be a bit of a gap between that final separation and payload deployment, as this stage separation places the kick stage in an elliptical orbit of Earth first. The vehicle is travelling at more than 19,000 kilometres an hour with an altitude of nearly 200 kilometres, and everything is continuing as expected with our stage 2 burn.
Battery discharge holding nominal.
While our last launch was a recovery mission furthering our development of a reusable launcher, this mission is not, but we will be attempting our first aerial capture of Electron in 2022. Meanwhile, Electron's vacuum-optimized Rutherford engine is putting in the work ahead of kick stage separation in about a minute and a half.
That stage 2 burn not detect mode.
Electron is continuing on its way to orbit, traveling at a speed of nearly 25,000 kilometers an hour and an altitude of over 190. Now, as I mentioned before, coming up next is second engine cutoff, or SECO, which will see the engine on Electron's second stage power down ahead of kick stage separation scheduled a few seconds after.
SECO confirmed.
We have had a successful SECO and second stage separation from the kick stage. Today's satellites are headed to a circular orbit, so while the kick stage is on that elliptical first pass, it ignites its Curie engine to course correct and set it on its correct trajectory for payload deployment. That's set to take place in the next 45 minutes or so. The A Data with Destiny mission launched at the top of the launch window today, lifting off the pad at Rocket Lab Launch Complex 1 at 1:02 p.m. New Zealand local time. Electron had a clean pass through max Q, main engine cutoff, first and second stage separation, and then second engine cutoff and final stage separation from the kick stage, carrying today's pair of BlackSky satellites to low Earth orbit. The kick stage is now coming up on payload deployment shortly. We will move through 3 events in the deployment process. First, one of the BlackSky satellites will separate from the kick stage in the right spot on this 430-kilometre circular orbit. Next, the extension of the upper stage that both kept that first satellite attached to the kick stage while protecting the second satellite beneath it. That upper stage extension will be ejected to make way for the deployment of the second and final satellite on this mission.
Global 16 separation confirmed.
So you will have heard from Mission Control there. That is the first BlackSky satellite successfully delivered to its new home on low Earth orbit. We'll clear some space between that satellite and the next maneuver, which is the ejection of the upper stage extension.
Payload adapters deployed.
There we go. That call out from Mission Control confirms we've had a successful separation of the upper stage extension. That clears the way for the final satellite deployment today, which should be taking place in just a few moments from now.
BlackSky Global 17 is deployed.
And there we go. We have had confirmation of successful deployment of that second BlackSky satellite. Welcome to your new home in orbit.
The two 60-kilogram BlackSky Gen 2 Earth imaging satellites will be used for real-time geospatial intelligence gathering. The spacecraft was successfully deployed into a 430-kilometre high orbit. The launch demonstrated Rocket Lab's ability to undertake back-to-back missions, which was also for BlackSky. The BlackSky constellation now consists of 12 satellites. Rocket Labs deployed 7 satellites into low Earth orbit for BlackSky, with 2 more expected to be launched on Electron early next year. The flight also brings to 109 the number of satellites launched by Electron over 23 missions. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has linked aspirin use with a 26% increased risk of heart failure in people with at least one predisposing factor for the condition. The findings, reported in the European Society of Cardiology journal Heart Failure, are based on an analysis of 30,827 people in Western Europe and the United States, with an average age of 67, 25% of whom were already taking aspirin. During 5 years of follow-up research, 1,330 participants developed heart failure. After adjusting for other factors, researchers found that taking aspirin was independently associated with a 26% raised risk of a new heart failure diagnosis. The predisposing factors included smoking, obesity, high blood pressure, high cholesterol, diabetes, and cardiovascular disease. A new study warns that by the late 21st century, northeastern cities in the United States will be experiencing worsening hurricane outcomes, with storms arriving more quickly but then slowing down once they've made landfall, lasting twice as long. The findings by scientists from Rowan University are based on more than 35,000 computer-simulated storm events. They show that as storms linger longer over the East Coast, they'll cause greater damage along the heavily populated corridor, allowing them to produce more wind, rain, floods, and related damage. The report, published in the journal Earth's Future, showed that the changes in storm speed are being driven by changes in atmospheric patterns over the Atlantic, prompted by warmer air temperatures. Bit of good news now if you're one of those people who need that first cup of coffee in the morning to get you going. A new Australian imaging biomarkers and lifestyle study has shown a link between coffee consumption and a lower risk of developing Alzheimer's disease. The findings by the Edith Cowan University examine the link between coffee consumption and cognitive decline in more than 200 people. Scientists found increased coffee intake resulted in positive results in a number of key areas of cognitive function, including executive function, which involves planning, self-control, and attention. The findings, reported in the journal Frontiers of Aging Neuroscience, also showed that higher coffee intake was linked to slowing the accumulation of amyloid protein in the brain, which is a key factor in the development of Alzheimer's disease. Researchers found that 240-gram cups of coffee a day could potentially lower cognitive decline by 8% after 18 months. It could also see a 5% decrease in amyloid accumulation in the brain over the same period. One of the most important events on the paranormal calendar, National Ghost Hunting Day, has come and gone for another year, and sadly, we missed it yet again. One of the highlights of this year's event was a ghostly gathering of researchers in the quaint English village of Leighton Buzzard. They were joined by fellow Ghostbusters at the haunted rectory cottages in Bletchley, the ancient pyramids in Cairo, and of course Dracula's castle in Transylvania. Sadly, no ghastly ghosts were seen, no spirits spotted, or ghouls grabbed. But the teams did get to show off their latest gadgets. As well as the latest in LED headlamps, torches and digital thermometers, indoor surveillance cameras were very popular this year, as were forward-looking infrared cameras designed to see in the dark and pick up temperature changes caused by a passing poltergeist or wandering wraith. This year, the K11 EMF electromagnetic frequency ghost meter was the must-have piece of basic ghost hunting kit. And yes, as the name suggests, it's basically a radio. Then there's the Ghost Box, which works by randomly scanning through FM and AM frequencies to pick up spirits' words in white noise. And in case you were wondering, yeah, it's simply a radio scanner. Then there are special devices designed to record the sounds of paranormal activity, or as you and I would call them, digital recorders. And of course, every good Ghostbuster must be kitted out in full military camouflage, although no one's really sure why. Tim Mendham from Australian Skeptics says National Ghost Hunting Day is a big event for true believers.
Basically, it's when paranormal hunters from across the world, or at least about a dozen countries or so, they live stream their walks. Right, they're walking through haunted houses or haunted locations or whatever, and this is live streamed around the world, and people sort of share their experiences on Ghost Hunting Day. Obviously, you've got to allow for time differences, etc. So something you have to watch all day to see this. So unfortunately, we missed it, but we'll look forward to it next year. But one place that intrigued me actually was a place in England. It's actually in the county of Bedfordshire called Leighton Buzzard, which I love the name of that place. Mainly I love it because I used to live there. Had very old pubs, which were very nice and obviously very haunted. But, Leighton Buzzard is actually, someone thinks it's a Latin Bodazar mispronunciation, but worthwhile going to see. Not the
Sounds
most
like
exciting
something
town.
out of an Agatha Christie novel, doesn't it?
It does, yeah. It's not the most exciting town, I must admit. It's got a nice market square and that sort of thing, but most English places too. But anyway, yes, National Ghost Hunting Day next year, September 24, 2022. So put that down in your calendar, and you go and look it up, and you can watch all these paranormal hunters, ghost hunters, investigators walking around their haunted houses and streaming their events, and you might end up seeing a Leighton Buzzard resident, or an Australian even.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.